All right, well, this is NoSQL to Postgres, not PostgreSQL, as I learned this morning. And I'm Phil Hildebrand, and I work at Moz, and we write tools for SEO, search engine optimization, basically for online marketing. And we have recently done a small migration of a NoSQL database called RethinkDB, well, a service using that, to Postgres. And there were some interesting things that happened, so I thought it would be fun to talk about those things, what we learned, and maybe what we'd do different when we do it again. So was anybody in the talk this morning? I think there was one on the top 10 things that people do wrong with migrating Oracle to Postgres. So after, let me know if we hit any of those things that we shouldn't have done. But yeah, so I thought I'd talk a little bit about why we chose to go to Postgres from Rethink. And then maybe look at some of the things that we think we did right, and some of the things that maybe we didn't do right or didn't go so well. And then maybe talk about what we're doing in the future, and feel free to ask questions along the way. A little bit about us. We've done a lot. At Moz we have a few different database backends. We're a lot of MySQL. We have a large Rethink database cluster, which is it's sort of a cross between MongoDB and Riak, if you're familiar with Riak. So it's a eventually consistent ring. But it has a Mongo-like interface, so it's JavaScript interface. We have Postgres, and we have HBase and Riak and a few other minor things. So we have two database engineers, me and Namrata here, and we basically manage all the back-end and systems there. So the product that Moz has a few different products, and the service product that we did the migration for is Moz Local, and it is essentially a system that manages companies have storefronts and their locations, so that across the different location entities like Yelp and Google My Business, things like that, that all your location and store, when you're open, when you're closed, that's the same across all these places. And then we also allow them to check their reviews, new reviews that have been posted on different sites. So we collect all that, and our customers can look at how they're doing and manage their SEO for local businesses. So at Moz, we have kind of a culture where each dev team can kind of pick the right tool for their system. And so over time, that kind of grows into more and more and more back ends. And so this was basically about 6 months ago. The system was it's a node-based system, and then we have SortDB, and that's basically a memory-mapped CSV file, very large on a SAN. And we use that for things that are read-only and things that maybe refresh once a day or once a week, things like that. And then we have MySQL that we managed the location information, any transactional stuff, and then a little bit of sort of the billing admin side of things. And then we had RethinkDB, and that was because a lot of the upstream information where we get our listings and our vendors that give us information about reviews, it's all JSON. So they were like, oh, we need a JSON database. This is so easy to set up. Rethink is really easy to set up and really easy for developers to get started. So that's where we went with that. And it quickly grew from 100 gig to about, I think right now it's about 9 terabytes, and we have 15 nodes. So fairly big, and we didn't really want to start with a 10 terabyte Postgres database. So one of the developers that started was a Postgres developer, and he was all about Postgres. This is so awesome. And he brought up that, hey, Postgres has materialized views. Maybe we could put SortDB in there for that. and maybe we could get rid of sortDB, and then, oh, and it supports JSON, so maybe we can replace Rethink with Postgres and do JSON there, and then it's transactional, so we can put our MySQL stuff, and then we would only have one, well, maybe a few others, but one core system, and so it would be easier to bring on new devs, which was troublesome in the past, especially since they weren't, sortDB isn't a common thing, RethinkDB isn't a common thing, and so this Postgres has a much bigger community. And then our BI team uses Redshift, which has a Postgres interface. And it was troublesome to get data from Rethink up to Redshift. But if it's Postgres, much easier to migrate up there. So that was sort of a side benefit. Yeah, and then primarily for the JSON. So, my background is Oracle, MySQL, some HBase. We have to do HBase. But one of the things we did good was we realized, well, Postgres, it's not Oracle, it's not MySQL. We can't just assume it's going to be the same thing. And so we looked at different things that we needed to think about. The first thing was the command line client. I was like, we can't do show databases? What's up? And that was actually quite difficult for us. The devs, most of them have their tool of choice, whatever, SQL. There's probably 3 or 4 or 5 different SQL interfaces they use. But for us, at least for me, this was a huge issue, /D/L/ whatever. Hopefully, I don't know, does anyone know? I would love to know if there's a sort of translate the command line client to MySQL command line client or something. Oh, yeah, you could just do select statements. You could do that. That would be awesome. Yeah. So yeah, we found that was difficult. It wasn't really a barrier for the devs, but for me it was. So that was the first kind of thing we ran into. And this is, let's see. Yeah, and so then we spent a lot of time just looking at the architecture different, right? And we looked at replication. How does that work? So with Rethink, replication is under the scenes. You just say, I want n replicas, 3 replicas, and behind the scenes it just makes sure that any set of data has 3 replicas everywhere in the system. So super easy. I don't have to configure anything. I don't have to do anything. It just set up. Postgres, obviously, it wasn't that straightforward. So we spent a lot of time looking at, what's streaming replication, what are the other things like that, and we did some tests and tried to get familiar with that. And it was a little different than, we know MySQL bin logs, but it was a little different there. And authentication and roles, Rethink doesn't have that, or at least the version we had didn't. So, we just told the network engineers, set up a firewall, and that's all we needed. We didn't have to do anything with roles or users, or a user is a role, which was an interesting concept that we didn't quite understand at first. So we spent some time working on that. And then failover and recovery with Rethink. A node goes down, it auto-replicates to make sure the data sets still have their 3 replicas everywhere. And you just put a new node in, delete the data file, and bring the node up, and it connects and replicates everything and just goes on. Not so much with Postgres. So that was a bit of learning. And we had done, we do MySQL, we set up everything master replication. So we're familiar with a little bit of the concepts, but that was when we spent some time doing some, in staging, just practicing how do we roll back, how do we fail over, how do we start up the secondary. With MySQL, that wasn't an issue. We didn't have to activate the standby database. So that was some of the things we focused on architecture-wise. And this was all before we started migrating anything. And so then the other area that with Rethink is super easy. There's 3 options to configure. What are the other nodes in the cluster? How much memory do you want to allocate to cache? And, what was the other? I forget the other thing. Oh, how much replication you want. N equals 3, N equals 2. Pretty much always N equals 3. So there really wasn't much configuration for Rethink. Postgres, you look at, can configure anything, have it your way. So we did use this PG tune. I found it a really great place to start with as someone coming into Postgres. And it's just a website. You put in what version, how much memory you want, and it just dumps out here's a default for you. And so that's kind of where we started. And really thankful that that's out there. Because it is a little overwhelming when you go through the docs and all the different options you can tune. So yeah, so the other thing was you mentioned select from PG. With Rethink, there's a few tables. There's your stats table. There's your servers table. A couple core tables. And servers, it's just a JSON document with everything about your servers in it, all the information. Same with the tables, single JSON document. So it's super easy to get the information you need. Stats, it's one JSON document that comes out. You just look at it. You can tell everything about statistics on that. Not so much if you look at the PG views. And so one of the things we did was we just looked around the web for people that had cool queries for things like connections, what are blocking clients, how much data is stored in the tables. And I have, we'll see. So we just made a list of different queries that we could go to quickly just grab and throw on and run. We found that really helpful getting started, and especially when it came to inheritance, which was something that maybe I learned way back when I was doing C++ programming, but for the user roles and stuff, I think somewhere down here, we did some stuff for replication to watching replication lag. Yeah, user roles, just quick things to look at. What am I inheriting? Does this user have super or whatever? And I do have that in the slide. It was something that I used to do when I did only Oracle. I would bring my list of scripts around to all the different places I worked. And GIST is awesome because a lot of people have their GIST public, and you can. And we tried to give credit when we found it on the web to who they came from. We didn't develop all these. But I do have that in the slides. So we found that super helpful for when, oh my gosh, what's going on? This is too slow. We could go and do this stuff. And yeah, and the inheritance, that was a new idea for us. So the nice thing is, since we knew MySQL, since I'd worked with Oracle, there's, oh, sorry. You can't see what I'm looking at. It's still a relational database, so a lot of those concepts we knew it. We'd probably have to monitor memory, connections. We'd probably have to monitor replication lag, because we know it's a master-slave scenario. And one of the things that Rethink didn't have the concept of vacuuming. So that was a new concept for us. I mean, we had heard of fragmentation, and usually with NODB on MySQL, you maybe rebuild an index to defrag it. So that was one thing we played around with. Was luckily they have auto vacuuming, and that's pretty much what we run with. But we looked at full vacuums, and so for our materialized views, before we refresh our materialized views, we'll vacuum the tables underneath it. So that was one area that we weren't as familiar with, that we played around with. So 3-6 months go by, not much happens. We do our homework, and the devs get their stuff all working. And this was in mid-December, so everybody's getting ready to go on vacation. They deployed it to production, and the lead dev went on vacation. And about 2 days later, we had our first outage, which was lots of fun. So I'm going to bring up and I basically copied our whole, oh, I'm already going forward, huh? Sorry. Copied our whole database in here. So basically, we only migrated a very small portion, the reviews, and it's basically a single partition table, partitioned by year. And then because some of our vendors give us, we can ask for, show us the reviews from yesterday to today, we can just get a short set. Some of them say, no, you have to get the full set again. So we have this materialized view that basically dedupes ones that we might already have in there. So it's kind of a crazy, I can show you, it's kind of a crazy, is that right? Deduped. It's kind of a crazy, oh, you can't even see it, huh? Oh, I thought it showed you the, who knows what I'm doing wrong? Oh, there we go. Yeah, so you can see it's all this crazy stuff going on. And I don't claim to know all the rules around it, but we support it. So anyway, we're going along, it gets deployed, and all of a sudden we start finding out that all the reviews, that people aren't seeing their new reviews. So we went in and looked, and we ran into a couple of things. We noticed that it was taking a super long time to do the review, refresh, and essentially we were exceeding we typically start our databases on a SAN. We're on premise, so we have a SAN. And so basically we weren't getting enough I/O throughput to refresh the reviews fast enough. So first thing we did was we migrated it to local SSD. So then that cleaned up everything. Everything was working again. Then it crashed again. Well, it didn't crash, but reviews started being late again. And that time it turned out that we had a cron job that was refreshing the materialized view, and someone was investigating, and they started another refresh. And of course, the refresh runs vacuum tables before, so we had 2 vacuum tables running and multiple refreshes running, and everything kind of stopped. So that was our first kind of experience. So now, and the other thing that the dev had changed right before they left, they were doing a materialized view refresh, just that, which means the view isn't available while it's refreshing. So Postgres has a refresh concurrently, optionally, and so they had changed that just before. And so that actually used more resources and caused more of the SAN, some of the additional I/O. It was still the right thing to do, but we didn't realize it before what was going on. So that was a tweak that we found out. But yeah, so we're still running with the concurrently so that you can access it well. And so our next issue, can I just alt-tab it? No. Was we ran out of space. And I was like, oh man, are they dumping that much data in there? That can't be. So the first time I was like, just add more space, and they kept extending the space. And then I was like, okay, I better look, because you can't be putting that much more stuff in there. And it turned out it was all wall log space. And so we were actually going through about 200 gigs a day, which was 3 times the size of the database, right? So I was like, what's going on? And we were only doing, for us, 400 transactions a second isn't that much. But the problem was there was 1.5K per transaction, and so it just got very big. And of course, we didn't have any auto archiving set up or anything, because that's kind of free with MySQL, and we didn't have that concept with Rethink. So that was one of the things we learned. And so we basically wrote a script that archives everything off to another place and then zips it up and moves it off, because we still want point-in-time recovery. Did you try wall compression? We did not. We don't even know about that.
There is a parameter called wall compression, which you could set to on, right?
That is awesome.
That's available for 9.5.
So there you have it. Do your homework, see?
And you also get a great performance improvement if you are writing your transaction logs to the same disk as the data.
Awesome.
And you could always go ahead and write your transaction logs to a different disk using symlinks.
Yeah. Yeah, so that would have been great to know, but we didn't know that at the time, and we didn't search for it. So we'll probably look into that. And we actually ended up using Z Standard. If you heard, I think Facebook mentioned it in a talk, we converted from gzip to Z Standard for our compression of the backup stuff, because we're using up so much space on our SAN. Not just with this, but we did it with that too. So that is good. I'm going to remember that. So that was our second one. It wasn't too hard to get out of. And then a few days later, the whole reviews table, the materialized view stopped refreshing. And we got this really cryptic error about some transaction, multi-transaction thing wraparound. And I was like, what in the world? This is crazy. And I saw two different references. One was about sort of long transactions, I think, and the other was torn page. And I was like, oh, maybe there's some kind of database corruption, but we just started using this. This can't be. Luckily, Postgres has a great community, and I was we don't have support for Postgres at the moment, and so it was kind of up to us, and it was, the lead dev was gone, so I was like, okay. And luckily, the forums are awesome, and so I posted on the forum what was going on, and we did read a few things about what to do to get to the point where I could post on the forum. So, but I just wanted to call out these guys that helped out on our giving information, because it was definitely like, it's been a while since I was looking at pages in a database to see what the data was and where it got corrupted. So I thought it was really cool, so I thought what we could do is kind of run through what we did for this. So this was the actual, and I have this was the actual ticket we opened. But I thought what we'd do is run through it. So the first thing we did was we narrowed down to, we realized like, hey, it isn't refreshing because of this error. So we tried to select data from each of the partitions, and we were able to select data from every partition except 2018. So then we went through and basically used like offsets to see, select whatever, limit 1, offset 20, offset 30, until we got an error, and we found the actual row. And then from that we were able to find the page that had the error. And so when we ran it, I think, that was the error we were getting. Multi-transaction ID has not been created yet. Really cryptic. At least for someone that is not. Kind of feels like an Oris 600 error if you're familiar with Oracle. So basically we kept going until we found, and we can actually do this. So, and I don't know if this is because the tear actually happened in the text part. So some of the data was valid, so we were actually able to get the CTID I think if it had corrupted the whole page, you might not have been able to get the CTID. I'm not positive on that. But so we found the CTID, and that tells you the page that was corrupt. And so then, and I should say, we did what they told us to do. This wasn't like us figuring this out. So one thing we learned is you have to enable the page. Has anybody used the page inspect extension? It's pretty cool if you're into weird database stuff. So I already enabled it in here, but you can just enable that, and it'll, I mean, this says it already exists, but it'll enable it. And so then you get all the page inspection views that you can use. And so they had me do a page jump, the raw data, and they gave me this query that basically says dump all the metadata about this page. And I mean, this page has since been fixed. We fixed our issue. But what they noticed, and I don't know exactly how, but they noticed in the infomask column that some of on the corrupt one, that there was ASCII showing up there and it should have been hex. So they said, well, there must be some corruption because you shouldn't see anything like that. I need to go back and ask them how they knew that. But hopefully this will never happen again. You know it will. So this is what, when we did it there, they, is this the right one? Are those the same? Yeah, so this is what it was corrupted. So they were able to tell from these that, and I don't know which one, but those they knew that these were incorrect. And this is what it should have showed, what we just showed. So then they had us do a dump, a hex dump, and dumped it to disk. And basically, I think in here, they have the actual command. I mean, it was, yeah, so here's where they basically just taking the raw reviews, doing a hex dump, and then doing an octal dump so you could see what the data was in the page to see if we could tell from the page what was wrong. And you can see here, if you read on the right, it says, pleased to hear that you had such, and for choosing us for your commercial vehicle. What this page should actually look like is, it's actually a bike shop that they're reviewing. Oh, wrong one. Still the wrong one. So we can get it here. So what it should have looked like was this. And so there you can see, so pleased to hear that you had such a positive experience. Thank you for being a valued customer. That's what it should have read. So it was just interesting. It broke in the middle of a text field, or basically it was overwritten by another record. And I was just super thankful for the guys on the forum that were able to help pinpoint this. And that's how we were able to verify once we restored it, that we restored the right stuff. So that was really, in theory, we could have skipped the whole what's in the page, just restore it. But we wanted to make sure that it wasn't already corrupt in one of our backups so that we had the right data. So what we did to restore it was, and if you're familiar with partitioning, a partition table, you just have the table and it tells you, here's all the tables that make up this. And we knew that the data was just in this one table. So we restored from backup, exported the one table and imported it into this as a new table. And I'm just going to simulate that by creating, and I can show you here too that it actually works. I think we have time. So, and because takes about 10 seconds. Because we're filtering on those dates, and that's the partition key, we're only searching that partition. So it would take a lot longer if we hit the whole thing. So I don't know whether that's 6 million rows, something like that. So then you can basically you have to create the table that you're going to move into so that it looks exactly like the other one. Now, if you're restoring from backup, we just restored the data and put it into a new table name when we restored it. But what we can do is cheat. Is that the right one? Yeah. And so reviews 2018 new. So you can verify it looks new. It takes care of making sure your index names are not going to conflict, anything like that. And so now we have an empty table. And so we can pretend to restore our data in there. So we'll just insert the data in. And yeah, so we got 10 rows in there. And so then all we need to do is switch the partitions out. So you do that by disabling or detaching the old table, which does technically make it unavailable for as long as it takes you to replace the other one. So if you have a script, it's pretty fast. I don't have a script here, but so once I do that, that data is not available for 2018. So like if I were to rerun the count, where'd it go? 0.
So the reviews 2018 table from where you selected, that's the corrupted one, right? That's the corrupted partition.
Yeah, I'm pretending it's the corrupted. It's since been fixed, but yeah. Okay. So the 2018 was the one that had the corrupted page.
So when you initially tried to copy the records from that corrupted, was it the same kind of insert that you used?
Yeah, so I cheated. We didn't do it that way. What we did was restored a backup and exported the one table from the backup that was good. And then we imported that table into this database as new. To skip all that, I did the whatever. Are you going to say we could have imported it right into that one table?
So you could, did you try setting 0 damage pages to off?
So we had looked at that, and I think what we decided was we were concerned that we might lose that record. Is that the case? Yeah. So he mentioned there's a way to say ignore the bad pages. And in this case, it might have been okay. Depending on your data, that might be okay. It was only one page in this whole database that was bad. And if that's a data warehouse, it probably doesn't matter at all. This is reviews. And technically, we refresh our reviews. Eventually, someone might comment on that review. Our nightly pull would bring it in, it would replace it. So technically, we probably could have done that. But we were a little concerned being Postgres newbies, so we got the backup and did it that way. So yeah, so you can see disable the partition. The data looks gone. It's actually still there. It's just not available to the reviews table. So then we can attach the table that we basically restored. Which hopefully I got that right. And we can run our count again. Is that the right count? Yeah. And 10 rows. So, and you can see I'm just pulling from the partition table. So So that's how we were able to, and as soon as we did this, we could do our refresh. Now, some of you probably noticed we did have a couple issues after this. And if you look at this, can anybody figure out what might have been the next issue as soon as we did the switch? It has to do with what we didn't have to deal with in Rethink was users and roles, right? See, I own the table. So, of course, I did it as the Postgres user. And, our service connects as a beacon service. So, of course, they're like, hey, there's no data. And luckily, they did get an error that they didn't have access. So that was one thing that we fixed. We had to change the owner to beacon service. And then the other interesting thing, which, that is weird. Oh, okay, I thought I was looking at this. So I was like, why is there still a reviews 2018 table and a 2018 new? To actually see your partitions, you have to say D+, yeah. So you can see it's only reviews 18 new. So the interesting thing that never occurred to me was that you can insert data into the tables underneath and not the main table, right? Which from Oracle and MySQL, I'm like, why would you ever do that? I don't know, but our developers were checking the dates when reviews were coming in, and they were sticking them into the partition that they knew they were for. So a 2018 review would come in, the actual statement they were running was insert into reviews 2018 instead of insert into reviews. So of course, I didn't bother renaming the table. So later on when a review came in for 2018, they got a table does not exist error. And that was the last piece that we had to do, was basically rename 2018 new to reviews 2018. Now, I would imagine that's not a common practice. I don't know if anybody knows, but in theory, they should have just been inserted into reviews and let Postgres do the partitioning for them, which is a bug I entered on their JIRA log. And that would have made it easier, because I think what complicated everything was the lead developer was on vacation, so it was the new guy and me trying to figure out what was going on over Christmas. Sorry. Let's get back here. Okay, so that was basically how we recovered. How are we doing on time? We're okay? Oh, cool. So if we did it all over again, I'd read up on, what did you say? Oh, compression for wall logs. Absolutely, I'm going to do that. The things that were helpful were, we did go through a lot of the docs. It gets boring. We created all those cheat sheets. We did a lot of automation. We use Ansible. So actually, they wanted to deploy a new database while we were here. So I said, here's our Ansible script. Have at it, but you support it till we get back. But it's awesome to have that kind of automation that someone can go build it, and it builds to sort of the bad standards that I set up for wall logs, right? And then, the good thing is we didn't try to migrate the 10 terabytes into Postgres. So we're going to do it in little pieces. We could have done more load tests. We probably would have found the issue with the wall logs. We probably wouldn't have found the bad page. And if you read through the thing, it turned out they think it was probably a VMware bug, because it tore exactly at 4K, which which shouldn't have happened since, which implied it wasn't a Postgres issue. And we would get involved earlier on, just from an advice perspective. So what we're doing next, we're going to migrate some of the MySQL data, which actually that's in progress now, into Postgres. And we have a better understanding of replication and materialized views now. And we're actually looking at maybe doing the logical replication. I think we do physical replication right now. So we may do that specifically for being able to upgrade your secondary without downtime. And then the wall segment size, one of the problems we had like 15,000 wall files a day because of the 64 meg, is it 64 meg? 16 meg sizes. So you can change that, but only at database creation, which we obviously didn't want to do that. So, but Postgres 11 is supposed to allow you to change that after database creation, I believe. So we would have liked to have maybe a 512 megabyte wall log when you're generating that much, or use compression and not have them that big. And then, yeah, we have the automation. We're doing Postgres 11. As we speak, they're deploying our production Postgres 11 instance, which is exciting. And we're using actually the GIS that they talked about, so that helps with our location stuff. And obviously, we'll do more load testing, hopefully. We'll see. I don't know how much they did. So these are all in the slides, but things we looked at, the docs, the PostgreSQL blog from Percona, Several Nines. Is anyone in here from Several Nines? They have an awesome beginner DBA blog for Postgres. Super awesome. PGTune. PGBench is just a load test tool. We wrote a DB loader because we have so many weird things. So it supports Mongo, Postgres, React, Rethink, hopefully soon MySQL. That's our biggest one. You'd think we'd have that. So you can look at that. And if you have tips or you use a different database, it basically is set up so that you can, it's modularized, and it's Python. And then those GIST queries, those are the things I had up there, the page inspection. And it's fun to do just anywhere. And then the forum issue, if you want to see where the real brains are. So anyway, I don't know if you have any questions. We have a couple minutes maybe, I don't know, 5 minutes. I definitely have questions for everybody. Yeah, so the review replies, those are JSON-B. Yeah, that is. And actually all of our, and the new service that's doing using the GIS, they use JSON, and it's all JSON-B, yeah. That I would have to, we haven't done the review yet of what they're doing, so I would hope so, but I don't know.
Just be aware that it can take a lot of disk space, the gym index.
Oh, okay. And that's the one that indexes everything. Yeah, okay. That's good to know.
But it's super cool.
Yeah, and I think from a dev perspective, it's sort of out of the box if you don't have to remember to index a field, right? Essentially within your JSON. And that is one of the cool things. That was one of the reasons we had Rethink, is you could index the JSON fields within it. And everybody thought Mongo wasn't a thing, even though we use Mongo. But yeah, so any other questions?
There's a company that lets you port Mongo to Postgres and then provides a Mongo interface with Postgres under the covers.
Really? No, I don't know. What's that called? Oh, okay.
Yeah, a company called Ongress.
Oh, okay. Ongress. Sweet. I'll check that out. Yeah. Oh, okay, that's cool.
So you can port to Postgres and then still use your Mongo client.
Oh, that's really cool. Yeah, yeah. Yeah, because we...
I'm not sure it is. So if you
Oh,
read,
okay.
take us offline. Yeah, if you read the text and like what it supports and the limits, yeah, there's some verbatim cut and paste. So people think it's a one-to-one count.
Okay, that's cool.
Definitely Postgres. I'm not sure. But anyway,
Yeah, because we are hoping to migrate out of our data center into AWS and
well, that company Turo or Toro, whatever it is, does it, and also
oh, cool,
Postgres.
sweet, awesome.
Do you know the reason of the performance issue on the materialized view request? Was it because of miscommunication or
So there was a couple. The first one was an SSD. We just couldn't write the data fast enough, and we could tell because we knew sort of that it was overutilized once it hit 200 IOPS, and so it was really clear that it was all I/O, and we were able to vMotion it onto SSD. The second one was because we had two vacuums running at the same time, and then I think the materialized view refresh over the materialized view refresh sort of messed things up. So that was more of just a combination of doing dumb things and not having checks to make sure that only one's running. We have a monitor now that checks like that it finished within a certain amount of time. If it doesn't, it pings us, or pings the devs, really. I say us. And, you know, I would like to do more performance testing on the materialized views. I think that you can see that that view is kind of crazy. There's probably a lot of tuning we could do just SQL-wise to help that. But yeah, the first one was just an I/O issue. So that was an easy fix. But the other one was we had to trying to refresh it twice. And so I don't know that it was actually a performance issue so much as things were waiting to get access to it. So, well, it looks like that is the end of the show. So rate my session, give me feedback. I'd love that. And then, yeah, if you have Postgres tips, we can use them. And if we made any of those 10 mistakes from this morning, the other class, I'd love to know. And I'd love to know what the others are. I'm going to go look at that one. But thanks for coming. And yeah.